Amplitude modulation is a process by which a wave signal is shifted to a certain suitable range of frequency for transmissions. It is commonly used in transmitting a piece of information through a radio carrier wave. This is equation for amplitude modulations. In AM, the voltage or power level of the information signal changes the amplitude of the carrier in proportions. With no modulation, the AM carrier is transmitted by itself. When the modulating information signal or a sine wave is applied, the carrier amplitude rises and falls accordance. The carrier frequency remains constant during AM. The carrier frequency is much more higher than the modulating frequency, as low frequency cannot travel long distance. The higher the frequency of the carrier, the more information can be transmitted in a given bandwidth. Modulation index, or known as M, is a measure of extent of modulation done on a carrier signal. It ranges from 0 to 1. When M equal to 0, there is no modulation, and while when M equal to 1, there is a full modulation. If M larger than 1, distortion will happen. Last but not least about amplitude modulation is the benefit of amplitude modulations. There are some benefits of amplitude modulation, which are increasing the efficiency, reducing the size of antenna, reducing the noise, and enabling multiplexing process.
I am Tan Kasing and I'm going to share about angle modulation. There is another type of analog modulation technique known as angle modulation. This technique changes the angle of the carrier signal by the amplitude of the information signal. The advantages are low noise, improved fidelity, and enhanced efficiency of power consumption, but it requires larger bandwidth and complex transmitter and receiver circuit. There are two types of angle modulation, phase modulation and frequency modulation. Phase modulation changes the angle of the carrier signal according to the modulating signal, while frequency modulation refers to the changes of instantaneous angular frequency of the carrier signal according to the modulating signal. There are differences between the two analog modulation techniques. From the waveform, we can observe that the amplitude changes, but the frequency remains the same throughout the amplitude modulation process, while the amplitude remains the same in the angle modulation, but the frequency varying. Angle modulation has better noise performance compared to amplitude modulation, but it requires more bandwidth.
I will explain about digital modulation radio. Digital modulation radio process is a process similar with analog modulation. In this modulation, the signal information is a digital signal, while the carrier signal is high-frequency sinusoidal signal. The advantages of this digital signal transmission is, first, it is immune towards noise and easily restored, regenerations, and also easy to measure. Like all the signal transmission, this digital signal also have their weakness, which is it requires large bandwidth. Analog signal must be converted to digital first. It is not compatible with analog system and also requires synchronizations on process. Amplitude shift keying is also known as ASK. This type of modulation represents the binary value with two amplitude. They are the amplitude of 0 for bit 0, while bit 1 is given with the maximum amplitude of the carrier. Information is in the form of binary, while the carrier signal is a sinusoidal high frequency signal. Two ways to produce ASK signal, which is using a multiplier and also switching technique. Look at this picture, we can see that using a multiplier, information signal will be passed through a low pass filter that filter out high frequency signal. After filtering the signal, it will be multiplied with high frequency signal. So the output signal produced is known as ASK signal. So the second technique is using a switching technique, which is the switch is open if the binary signal is valued at 1 and closed if the binary signal is valued at 0. This process will repeat and it's depend on the 0 and 1 binary signal. The produced sine signal will pass through the band pass filter, which limit the bandwidth signal. Move on to the ASK receiver. The first one is by using the envelope detector. This detector consists of rectifier, which will allow the signal from positive part only through it. Then the signal passes through a low pass filter that limit out high frequency signal. The output original signal. The second one is a synchronous detector. This detector requires an oscillator where the frequency is set to the carrier wave frequency. Modulated signal will undergo the process of multiplication with output signal, and the low pass filter is used to filter out the high frequency signal. Next is frequency shift keying. FSK is a combination of two baseband signal of amplitude shift keying. FSK signal can be generated by using a switch that can function to provide a different signal frequency. If switch is closed, the carrier frequency FC2 will open, and if switch is open, the FC1 will function. The open and closed switch value will result in two different frequency signal. The other way to generate FSK is to use a device known as voltage controlled oscillator (VCO). This device work when it can change in frequency when the amplitude of the voltage is applied to it. If voltage 0, it will produce a frequency. If voltage maximum, then different frequency will be generated. First FSK receiver is using the asynchronous demodulator concept, which is used to filter tuned to two different frequency. The filter with high output indicate either the logic 1 or 0. The output of logic comparator is called information signal. Last but not least, receiver of demodulator using FSK synchronous. The uses of low pass filter will allow the signal digits representing the desired signal to pass through it.
Phase shift keying is the modulation of the phase of a carrier signal to represent digital data. We can see the carrier phase output shifts when the digital input signal changes condition from logic 1 to logic 0 or vice versa. The advantage of PSK is having a lesser noise than ASK signal, as it can be reduced using multi-level concept. Thus, more bits can be sent over a given time. This is known as M-array phase shift keying. From the equation m equal to 2 to the power of n, m represents the number of levels while n represents the number of bits. The quality of transmission of information increases with the number of levels. For example, quadrature phase shift keying, which represented by 2 bits, it allows the signal to carry twice information as ordinary PSK using the same bandwidth. It is more efficient and has a very good noise immunity. The constellation graph of QPSK composed of the in phase, which represented by cos omega t, and quadrature, which represented by sin omega t. By comparing the amplitude of each segment, we can easily determine the digit bits and the phase starting from the anti-clockwise direction. For example, positive cos omega t and negative sin omega t equal to positive 1 and negative 1. Positive 1 equals to logic 1, while negative 1 equals to logic 0. Thus, the logic is 1, 0 at degree 315.
Hi, I'm BINTI. Now I would like to share about the latest advancement in the communication field. So the most popular one will be the 5th generation technology, which is known as 5G. I believe everyone have heard this 5G before, but what actually it is. So it is the latest standard in the mobile network technology. It succeeds 4G and offers significantly faster data download and upload speed, wider coverage, and more stable connections. So what makes 5G different? Actually, first is it provides a diverse frequency usage. We mean that have frequency band from lower band to provide a better coverage and higher band for increased data speed in the densely populated area. The second one is lower latency. So what is meant by latency? Latency is the time required for to transmit the data from one device to another device. So a 5G ability to have a significant reduce in the latency, it provides an ability for us to have the real-time interactions more better. Third one is a greater data capacities. So it's able to accommodate a massive number of connect devices simultaneously and support a growing number of IoT. So this is the impact and benefit of 5G to the society, environmental friendly. So actually 5G consumes less power compared to the 4G, so it's more energy efficient, we can say. So it's very good for our environment. So for the case of medicines, actually it's help in the patient monitoring and the quick transmission of large medical data set from one place to another place. So 5G provide a low latency, so it enables us to have a real-time interactions is actually contribute in our autonomous vehicles. So imagine that the vehicle can communicate with each other and with traffic infrastructures to improve our road safety and traffic efficiency. There's a misconception about the healthcare risk in the 5G. So some people believe that there is the 5G radiation as a source of cancers for the human bodies, and they can weaken the human immune systems to make it susceptible to the spread of COVID-19. Is it true? Actually, it's not, because there are no any studies that prove that there's evidence that show that there are harmful effect from the 5Gs. And we need to know that the 5G is non-ionizing radiations, so there's no any proven link between the 5Gs with the COVID-19 spread and the cancer. There's a misconception about the healthcare risk in the 5Gs. So some people believe that there is the 5G radiation as a source of cancers for the human bodies, and can weaken the human immune systems to make it susceptible to the spread of COVID-19. Is it true? Actually, it's not, because there are no any studies that prove that there's evidence that show that there's harmful effect from the 5Gs. And we need to know that the 5G is non-ionizing radiations, so there's no any proven link between the 5Gs with the COVID-19 spread and the cancer. So that's all for our group. Thank you.